All right, so what I did yesterday is I didn't get to I write down on that side, so I'm gonna rewrite all those. It's help Gia of so focusing on those. So I want to have a different color, and I will show you why those different color is. And we already talked about it yesterday, but we start with a 0, 90, 180, 270, 360. And we also said it's 45, 135, 225, and 315 is half of 90. So from here to here is 45 degrees. So from here to here is also 45 degrees. So therefore, the reference angle of 135 is 45. So all the purple angle has exactly same quadrant if I say reference angle. Remember yesterday we mentioned what is a reference angle? Reference angle is angle from for the terminal side to the closest x-axis, And the angle should be between 0 to 90 degrees because it's in the first quadrant, or between 0 to pi over 2 because I could be representing radians. So it could be 0 to pi over 2 or 0 to 90 degrees. That's what the reference angle was talking about. So that's why I color code all the purple part have the same color. Is that okay? Now I'm going to go to different color. I'm going to go to 30 degrees. So this is the green. This opening is 30 degrees. Arthur, what will be here? Don't look at it. Look at here.
I already looked. 150.
Okay, so 150. So don't cheat on the next one. What will be the next one here? 210. Good job. You don't need other people help you. Okay, Elizabeth, since you're helping him, you must know this one.
330.
330. Good. So that's 330. Because subtract 30 from 360.
I added it to the wrong.
Okay, that's okay. Now we also talk about the brown one is gonna be 60. Nicholas will be here. 120. And give me one more. 240. Good. I like that. And last one, Yasmin. 300. Okay, good. Okay, so now we got 3 different color. All the color is gonna be have a same first quadrant reference angle. So that just say, can I ask you a question? What's the reference angle of 210? 30. Because from this is 30. Because this is 30. This is closest x-axis. That's why they have the same color. The skim is that way. Terminal side is this one. This is called terminal side.
The opposite?
No, terminal side is the 210, right? This is a terminal. And this is closest to x-axis. This is 30 degrees.
Like, what is terminal?
What about the other?
Terminals means this way. This is line here.
Oh, okay.
Means from here to here. From here to here. This is called initial side. This is the terminal side. So initial to terminal is 210 degrees.
What if you went down? Isn't that closer?
Huh?
Isn't that closer if you go down?
If it's closer, it's gonna be negative angle. And you're gonna be like, there's no such a thing as a negative angle. But in unit circle, it does have a negative side. So it depends on orientation of the clockwise or counterclockwise. If you're going clockwise, it's negative. If you go counterclockwise, it's actually positive. So it's actually like, so for example, if I go in from here to here, that's positive 360. If I go in from here to here, that's negative 360. Because the clockwise start at this part.
But why wouldn't you go to 225 from 210? Because it's closer.
Yeah, 225 to 210. No, it's 225 to the closest x-axis. So this to the closest axis is 30 degrees. So that's why the reference angle is that one. Okay, what's the reference angle of 300? What's the reference angle of 300? It's not 50. It's a 60. So it's a 60. So see this? It's 60 because this opening from here to here is same opening from here to here. So that's what same reference angle mean. Reference angle is based on the first quadrant. Any question about that? Robert, can you tell me what's reference angle 225? Good. So you understand that. That's good. Okay, so now that data is gonna help you. So here we're gonna figure out all the zeros. So I'm gonna do the zeros here, the pi here, the 2 pi here. And we say this is a pi over 2. This is a pi over 2 because of half. So you go in 0 to 180 is 180 is pi. So therefore that's going to be pi over 2. And this is going to be 3 pi over 2. Now here's the thing though. Pi is a very interesting because a pi can be rewrite as 2 pi over 2. Or 3 pi over 3. Or 4 pi over 4, right? Or 6 pi over 6. Do you see that color scheme? The pi over 6 is where the error is. So you understand that. Also understand 2 pi. 2 pi can be 4 pi over 4, 4 pi over 2. Or brown, it's going to be 6 pi over 2. Or 6 pi over 3, sorry, 6 pi over 3. Or the purple is going to be 8 pi over 4. And the green is going to be 12 pi over 6. So you can rewrite that whole number to different fraction of 16 or 12 over 6 or 8 over 4. Does that make sense? That keep it account. Like how do you get to here? So if you understand right now, it's going to be really helpful. So we know this is pi over 2. So Elizabeth, not Elizabeth, sorry, Darshini, can you tell me what is this one here? Don't look at your paper, look at it here.
Two pi over 3 pi over 4.
No.
Is it like the 45 divided by 180? Like 45.
Yeah, you can do that, but that's gonna take too long. But visualize, if this is a pi over 2 and this is a 0, what do you think 45 is what? So this, you can figure out what the radian of this. Give it a try. It's okay if you got it wrong. We are gonna laugh at you. No, I'm not. Just kidding.
It would be like 9 pi over 2.
No. Okay, Yasmin, you wanna help out? Why do you think it's pi over 4? Can you explain to Darshini why it's pi over 4?
So from 0 to pi over 2, you have to like cut pi over 2 in half. That's just pi over 4.
So imagine if we have a half a pizza, and if I cut it another half, you're gonna get a quarter pizza because this is a half, right? From here to here is is half. So if I cut it to half, would it be pi over 4, right? Does that make sense?
Yeah.
Okay, so I'm gonna ask you a question until you get it. What do you think this one is? And other people still thinking too.
Pi over 6.
No. And let me ask Justine. What do you think this one is? Alexis, don't help her. You helping her, you're just waking her.
Is it 3 pi?
Yes, good job. So you always have, Alexis, I know you have a tendency you want to help somebody. Don't help them because you're helping them, you're hurting them. So they have to figure out on their own. She can only eat for herself. She cannot eat for you. So you have to understand that. It's okay. You got this. And you got it wrong. I'm just gonna laugh at you and we'll move on. It's okay.
Can you explain?
Yes.
Can you explain?
We only left.
Can I explain it?
Yeah, can you explain why?
Justin, can you explain to Arthur why is it 3 pi over 4?
I took it was the 45 bases 4, and then it.
She's on the right track. Don't worry. Be confident.
pi 180, it's pi, but it could be 4 pi over 4.
Okay, 4 pi over 4. We also see that 4 pi over 4.
And then you subtract 1.
Yeah, so this opening here, right? This opening is pi over 4, right? They have same reference angle, right? This is pi over 4. So I can take 4 pi over 4, subtract pi over 4, equal to 3 pi over 4. Does that make sense, Arthur?
I think so.
Imagine that pi is 4 pi over 4. And the reference angle is pi over 4, so we can subtract them.
Okay.
Subtract them backward. So with the same logic, Nicholas, can you tell me what is this one is? Don't look at your paper, look at here.
It's already over 4 using
Oh, I understand.
I'm gonna ask you.
3 pi over 4.
No, we already have 3 pi over 4. It's right here.
Oh. 6 pi. Or no, 5 pi.
Yup, is that correct? 5 pi over 4? You agree?
Yeah.
Are you sure? Okay. Darshini, do you understand it's a 5 pi over 4? If you don't understand, we're not gonna move around. We just make sure everybody understands.
Can you explain it though?
Yeah, of course. This is a 4 pi over 4 is already right here, right? Now the from here to here is 45 degrees, right? 45 degrees pi over 4, so it's just basically add pi over 4. So 4 pi over 4 plus pi over 4 is equal to 5 pi over 4. Okay? Arthur, what will be this one?
1.
You are a genius. He didn't look at his paper too. Well, he anticipated I was going to ask that one. He looked it up before
I did.
I know you. I know you. Okay, so now you know all the pi over 4.
Again, I'm gonna bullshit.
Okay, so for 30 degree, so Luke, can you tell me 30 degree? What is that? Don't look at your paper. Don't skim down.
For which one? 30 degrees?
30 degree. What is a radian?
It's the pi over 6.
Pi over 6. Good job. So that's pi over 6. And let me ask some people I never asked, which is Robert. Robert, what do you think this one is? 5 over 6. Robert, you're a genius. How about Roger? Can you Roger? Robert and Roger. Here. What about this one? 7 pi over 6. Roger is genius as well. Okay, so Josiah, can you tell me this one?
Is it
Come on, Josiah, you got this. He's got it. Don't worry. Don't help him.
Is it? Would be 11 pi or 12. Not help him.
No. Don't help him.
I'm not even gonna
Don't help him. Don't help him. He doesn't need help. Huh?
It's 6.
Okay, so what is you say it's over 6 on the top or 6 on the bottom? Okay, 6 on the bottom, and then we'll be on the top. The rest of you guys, you got to think as well. You cannot just. Come on, Josiah. So what is it? Good job. 11 pi because of the subtract from 12 pi over 6 to subtract pi over 6 to get 11 pi over 6. Does that make sense, Arthur? Okay, so the brown one. So what we're going to do with the brown one. This one's going to be pi over Chase. 60 degrees is gonna be pi over what? Pi over 3, good. And Chase, don't look at your paper. What is this one?
That is 2 power 3.
Good job. Yes, yes, you gotta eventually see those patterns. Justin, can you tell me this one? Maybe Arthur can help her out this time.
I was literally just Alright, I was gonna ask, what do you think you're asking wrong? Okay, like as in 2 pi over 3, right? You should track what?
No. You go with this part. It's easier. Go with this part. Go with the x-axis. Easier. So if you think about it, right? Yeah. So if you think about it, from here to here is what? Pi over 3, right?
Yeah.
Justin, from here to here is pi over 3, right? So from here to here is also pi over 3. So you just subtract the 3 pi over 3, go backward to get 2 pi over 3. So this one's gonna go forward. So it's gonna go forward. So what is that, Justin? 4 pi over 3. Good. Arthur, can you tell me the last one?
6 pi over 3.
No, 6 pi over 3 is right here. This is 6. This is 6 pi over 3.
Hold on, move up on the graph.
So it's gonna come back.
So it's gonna lose.
Yeah, gonna lose.
Not pi over 3, is it?
David, you wanna help out? This one. Can you teach your Arthur why it's 5 pi over 3?
You know how if you cut it deeper, it's gonna fix like this. You go 1, 2, 3. Next one. 5. There you go. I said it was gonna lose.
Yeah, you lose from 6 pi over 3. You lose 6 pi over 3 from 6 pi over 3.
Oh,
So it's 5 pi over 3.
I see now.
Okay. So remember that yesterday we talked about this unit circle is not as big as the same. So this is actually coordinate. This is actually coordinate. So if this is a coordinate, this is going to be 1, 0, 0, 1, negative 1, 0, 0, negative 1. Is that okay?
What was that one? Oh.
So this one's a 1, this is 0. Why? Because we talked about yesterday, unit circle is just as big as this. We talk about how big that unit circle is. Basically 1 radius. It's called unit. 1 unit circle. Unit circle. That's where the name come from. Unit circles. Okay, so this is a 1, 0. This is 0, 1. This is negative 1, 0. This is 0, negative 1. Is that okay? Surprisingly, we almost finished. But we're going to go back to look at geometry. On your SAT, there's a geometry part. And on SAT, you got to learn this. Shh, pay attention. Instead of whining, complaining, or shaking your head, you can just pay attention. The problem is you don't believe in yourself. You automatically shut yourself down. It's like when you go into a race, Elizabeth, you're like, oh, I'm facing number 1 in the country. I'm not going to win. No, you put your shit out there. You try to win. You kick their ass. Your mind has to kick their ass before you kick their ass. That's the way it is. You cannot just say, I'm losing. Those teams are way better than me, way faster, way stronger, way taller. No, that's bullshit. Okay, shh. Now, we're going to go back to geometry. This is geometry teacher did not teach really good, and I'm going to reteach you again. It's called isosceles right triangle. So this is 45 degree, this is 45 degree, this is 90 degree. It's called isosceles right. This is on SAT. This is a congruent because they are isosceles. They also have a ratio of x, x. What's the other side?
2x.
No, no. What? No.
Why?
Devin? What will be this side?
I think it was x times square root of 2.
Times Luke, right? Luke, what you say?
It was like x square root of 2.
X root 2. You have to memorize this. And if you don't understand it, it's okay. I'm going to teach you why that x square root 2. If you remember, if a Pythagorean identity, I take one side x squared plus the other side x squared is equal to the c squared, right? So remember a squared plus b squared equal to c squared. Do you remember that?
Yeah.
Now this one's 2x squared equal to c squared. Solve for c. C is equal to square root 2x squared. So it's going to be x root 2. So that's why it's x root 2. It's Pythagorean identity. It's not coming from nowhere. It's coming from somewhere. It's coming from Pythagorean. With that being said, okay, I'm going to give you a pop quiz. So if this is a 45, if this is congruent, this is congruent. I didn't say it's 45, and I'm going to tell you this is 90. And if this side is 8, this side is 8, what will be this side? Shh, I'm going to call you. Amber, what will be that last side? The hint is right in front of you.
Oh, 8 square root of 2.
Yes. Does that make sense? Because this is x, this is x, this is x root 2. That's it. So easy. This is on your SAT.
Like whatever.
Yeah, but the question could be asking the other way. So what happened if the question is asking the other way? Now this is the harder question. The harder question is, what if I have this one is congruent, this one congruent, this is 90 degree. It also implying 45, 45, 90, right? So what if this side is 10? What will be the other side? Ooh, that's gonna be kind of hard, right? If that third side is 10, what will be this side and what will be this side?
Oh, that's what we
Sure, yeah, what do you think? This is an SAT question right here. I'm helping you SAT review. I know you know because you're good at SAT now. Look.
What did that make it? 5/2.
Sure, yeah, no?
No, wait. I'm trying to rush.
Chase? You didn't get it yet?
Is it?
I don't want you. You have 1340 on SAT. You should be smart enough to figure it out. Yeah? 5/2? No. No. Anthony. 5/2 is correct. Okay. Why is 5/2? You're gonna take this 10 and you're gonna set it equal to this. So it'll be 10 equal to x root 2.
Well, that's pretty smart.
No, x, sorry. X root 2 like this. Sorry. It's gonna be like this. Now you solve for it. So it'll be 10 over root 2 equal to x. Is that okay? And then you rationalize by multiply by square root 2 square root 2. So it'll be 10 root 2 over 2. And this is equal to 5 root 2 equal to x. So therefore, this is a 5 root 2, and this is a 5 root 2. Imagine this is a 5 root 2, and if you do this, you plug in here, what will happen? 5 root 2 times root 2, which is 10, right? Makes sense.
Can you show it?
Microphone? Yes.
I did something different, but I got the same weight to it. I just said that 2x squared equals 100, and then I said that.
You can do that. You can do that.
And then I just
Yeah, you use Pythagorean identity, not problem. I would rather use ratio because ratio is gonna be faster on SAT. You only save about 10 or 15 seconds on SAT, but still, every question you save 10 seconds, it counts. So if you know how to do that, you can do that. If you didn't save enough time, then if you do it faster, then it's good. Okay, so this one becomes 5 root 2. Is that okay? So I'll give you a try again. What if this length is, again, this is congruent, 90 degree, and this is 12. What will be this side and this side? This is geometry. No, geometry is probably, I think I love teach geometry more than a lot of subject actually. I know Miss Lewis from
Oh my God, you know
From-
Miss Lewis?
she's so bad. I feel like Madison's good. Madison's good. Madison's a great teacher. Madison's a great teacher. Okay, so what you guys get? 6 root 2. Yeah, you said this 12, right? Equal to x root 12 equal to x root 2 because it followed our pattern. So 12 equal to x root 2 like this, right? And then you can rationalize, so be 12 root 2 over 2 equal to x. And this cancel out 6 root 2. So x equal to 6 root 2. 6 root 2. 6 root 2. Now, here's the thing. I'm going to go back. I'm going to show you where is that from. This is a reference triangle, and we're going to show you this reference triangle right here. So this, sorry, let me go use this one. This one is the reference triangle here. It's not reference angle now, it's reference triangle. We're going to drop straight down to form a 90 degrees. And this 90 degree is right here. And it's going to form here, right? Now we know this is 1, right? Because there's a radius. Radius is 1 unit. So the hypotenuse has to be 1. So can you figure out this side and this side? If the hypotenuse is 1, what will be the, because this is composed of this x coordinate and y coordinate. What? Root 2 over 2. Good. Why? Because 1 is equal to x root 2, right? X equal to 1 over root 2. And we need to rationalize it. So square root 2, so that's equal to square root 2 over 2. So this is going to be square root 2 over 2. Because the radius is 1 of the circle. So we know that root 2 over 2. Is that okay? So guess what? We can apply to this to all the reference triangle. But remember, inside a coordinate, Cartesian coordinate, this is a plus, comma, plus, right? This is a minus, comma, plus. This is negative, negative. And this is a positive, negative. So what does that mean? That means this is negative square root 2 over 2. Square root 2 over 2. And this is negative square root 2 over 2. negative square root 2 over 2. Is that okay? And this square root 2 over 2. This is negative square root 2 over 2.
It's just like a graph.
Huh?
So it's just like
Yeah, just like that. It's like, it's depend on the quadrants. Yeah, negative. So this is negative. This is both negative. Is that okay? Okay, I have 7 minutes to finish this, but we're gonna talk about the other triangle. So it turns out all the triangles are the same. It's like a butterfly. This is, I call it purple butterfly right here. Right? There's a purple butterfly right here.
How cute.
Thanks for the input, Element.
So this is the butterfly. This is called a reference triangle. They have 4 different parts. They all represent same exact coordinate. It's just plus or minus. That's a difference. That's only the difference. So all the things here, they all have same square root 2 over 2. Yes.
So what's that triangle called?
What triangle
Like
called?
one of those, like one of the halves.
It's called isosceles right triangle. This is isosceles right. This is isosceles right because this is a 45 degree. This is a
Yeah,
45
but what
degree.
about if you put another isosceles right on it?
Then it's still isosceles right in this particular one because it's this way. So this is 1 1.
Oh.
It's still isosceles right, but you know that's not the point. The point is the reference triangle. Okay, so we're gonna show you a fatter version of this butterfly. So we can have fat shaming a butterfly, I think. So
It's okay.
so I'm gonna go with green, and this is the green one. Okay, so this is the first one here. The first one is gonna be 1, but you gotta remember the second ratio. Let's talk about second ratio. The ratio that you're going to have for this particular part is this triangle is called 30, 60, 90. So this is 90 degree. This is the 60 degrees. This is 30 degrees. You have to memorize this ratio. This ratio is always on SAT. But if you don't memorize it, it's okay. It's on the first page or reference page. So if you look at a reference sheet, this is going to be X. Is that okay? This is always X. The 30 is facing the smaller side. The 90 degrees is facing the bigger side, so it's double. Is that okay? Now 60 is going to be facing something right in between. So the best way to remember it is this is going to be X times square root 3. This is kind of hard to remember, but it's X times square root 3. So 30 is facing X root 3. Now remember, I'm going to give you some geometry problem. I'm going to just ask you. What if this is a 30 degree, this is 60 degrees, 90 degree, and this is 2? Can you figure out what is the X, what is the Y? Roger, what's Y? Nicholas? 4 is good because it's double of this one. This is a 2, right? So this must be double, right? And what's this side? Two root 3, right? That's it. Is that easy? Okay. Remember, we have a reference triangle right now. And we have the size 1. Remember, this here is 1. So, and this angle here is 30 degree according to this, right? This is 30 degrees. So if I have 30 degrees facing here, this is 90 degrees, this is 60 degree. What is this side and what is this side? If a hypotenuse is 1, what will be the x value, what will be the y value here? Which one's 1/2?
Oh.
The small one, so this is, you can visually see it, it's 1/2, right? And this one is gonna be 1/2 times square root 3, right? Which is square root 3 over 2. So visually, you see this is a short side. If it's a short side, this must be 1/2. Sorry, 1/2 is this way because it's a y value. This is the y, right? This the x is going to be square root of 3 over 2. So it turns out that you can do this negative square root of 3 over 2. And this is a 1/2. This one's a negative square root of 3 over 2. This is a negative 1/2. And this is a square root of 3 over 2. And this is 1/2 negative. So we finish all of them. But the third one is actually something we already know, because there is no difference between the triangle for the green triangle here. The green triangle is no different than the other one. Sorry. Let me show you. So this is the wider version of butterfly, right? It has wider on the width, right? But shorter on the wing. So now what happened to the other side? The other triangle here is no different. So I'm going to show you the brown side. So it's going to be here. What's the difference between the green triangle and the brown triangle? What's the difference? The x and y just swap. Why is it swap? You take the green triangle, if you stand it up. If you stand it up, they have exact same shapes. So this one here and this one here are exact same shape. It's one just standing up. So if it's standing up, you just have to swap this value. Says this x is 1/2. And this is square root of 3 over 2. And this is negative 1/2. This is square root of 3 over 2. And this is a negative 1/2 square root of 3 over 2 negative. And 1/2 square root of 3 over 2. Wow, perfect. All right, tomorrow test, 7 minutes. I can give you a copy. I can send you the copy. You can print out as many as you want, but you have to finish in 7 minutes without a single mistake. Not even with a sign, not even with things. You cannot say 2 pi over 6. You should say pi over 3 instead of 2 pi over 6. Does that make sense? You should simplify everything. You don't have to fill in positive, negative. No. Huh? You got it
to this part, right?
We're gonna do that next. Huh? Hold on a second. Now, do you have printer at home?
No.
No, I'll give you one.
Okay, thank you.
Okay, I can airdrop to you. You want anybody want to airdrop? Are you sure?
Yes.
You have printer?
No.
If you don't have printer, I'll give you one.
Okay.
If you have printer, then
Oh yeah, I'll need to print it for me. No guys, I'm not gonna have no guys.
Mr. Riggs, you think it was
can somebody put on WhatsApp? Shreya, can you put on WhatsApp? We're not doing the backside.
I got it.